And just want to remind you of places to get some help and stuff like that. And that is, don't forget about your pals over there in the SI people. So just to remind you guys, also remember, every Friday, also today, every Friday we have our own review session in Fretwell 113. It is at 2 o'clock. At 2 o'clock till 3:15, Fretwell 113, where we sit there and we'll answer any kind of questions. And you guys are beginning to see some of the more difficult aspects of the class in terms of web work and stuff. So we'll be doing lots of web work problems for you guys on that stuff. Section 6.3, and we're going into section 6.4 big time today. So, but also you've got the SI supplemental instruction, new stuff called PALS now. Mondays 2 to 3 and Macy 201. Tuesday Fretwell 120 from 11:30 till 12:30. Wednesdays from 4 to 5 and Macy 201. And on Thursdays from 11:30 to 12:30 in Fretwell 120. So please go see these guys. You need some help, and we're trying to give you guys every possible way to get some help. Also, don't forget also about the Math Resource Center, Math Learning Center across the hall from the math department, third floor Fretwell. Open tutoring. You walk in there and the grad students just sitting there waiting to help you out. But it's open tutoring, so they answer your question, they move around and help out somebody else, and then they'll come back to you later. So another great resource and stuff. So, but you have got to be the one to go seek out this help. No one's going to knock on your door and sit down and explain this stuff to you. You've got to go find the help. Okay. So last time we just got started on and was working with table integration, and remember, table integration is use substitution. But instead of making you memorize these formulas, we're going to basically look them up in the CRC hand table, and for us, the back of the textbook. And I printed these things out for you guys. This is actually the back of your textbook and stuff. But these integral forms are based on styles. So depending on the style of problem you got, this is how you look it up. And they're all based upon the variable u for that use substitution concept. So, but the last thing is, remember your steps of use substitution. Number one, you got to find u. Then you take du. But here's the important thing now. You're going to convert, when you take the derivative, even if you got a function in front of your dx, you move it to the du side. You'll replace the dx, and then you convert that function in terms of u. So if you've got constants or variables, you move it to the du side, and then you substitute it in. So this makes it a little more powerful with this substitution aspect and stuff. So again, watching the pre-section videos, I did these problems for you guys, and you saw that moving the e to the x to the other side type concept here. And we did a little bit of the algebra review and analyzing a bunch of stuff with that u squared look to it. So I thought we'd pick it up with this example here. Now, here's the deal. A lot of people try to do this section in backwards. So I'm going to show you guys the way you should do this particular section. And what I mean by backwards is this. And this is something you got to train yourself for. You get yourself a problem right here, and this is not a formula I have memorized, and it doesn't look like anything I've ever seen before. All right? People will automatically start fumbling through the hand tables and stuff like that, trying to find this particular function. You're looking at it all wrong. What you got to do is, when you got to identify the style. When you look at this problem, this is the integral of 25 minus 4x squared raised to the 3/2. It looks like this a squared minus u squared look to it. And we have in our section of tables, we got forms involving the famous square root of a squared minus u squared. And that's what this thing looks like. I know it's to the 3/2 power, but remember, half a power is a square root. So it's in this format. So that's where I start. Before I start looking for formulas, I'm going to convert this thing into what the tables are going to look like. So here, I see that the a squared is going to be 25. That's going to force the u squared, that's your variable part, is the 4x squared. That makes a equal to 5, but it makes u equal to, if u squared is 4x squared, what does that make u equal to? How about 2x, because you take the square root of both sides, right? But then it is u substitution, which means I got to do du, take derivative. The derivative of 2x is going to be 2 dx, and whether as a variable or a constant, don't care, move it to the du side. So now 1/2 du equals dx. Now I'm going to substitute. This was the integral. 25 was a squared minus 4u squared, I'm sorry, 4x squared was u squared, raised to the 3/2, but wait, the dx gets replaced with 1/2 du. And where do we put the constants? In front of the integral. So that's the part you're going to have to keep up with because the extra constants float around. 1/2, and then I put the du in the back. At this point is when I start looking for the tables in the back of the book, okay? This is forms involving a squared minus u squared, so we'll go to that section. This one is forms involving the square root of a squared plus u squared. That's not it. Forms involving a squared minus u squared. Yeah, that's it. And then I'm going to look for that thing raised to the 3/2 power. Now, this is going to be web work. Web work is going to ask you, hey, what formula number are you using? And this is formula number? 17. Nope, not 17. Try 37. All right, number 37. And again, web work is going to ask you what is that formula number. And it's corresponding to the Dr. Stewart's back of his textbook and these sheets that I printed out from the textbook. So these are the numbers that you're going to need for web work. So formula number 37, so this is going to be equal to 1/2, and here it comes. Let's take a look at formula number 37, and I'm going to blow it up a little bit here for you guys in the back. It's quite a large one. It says negative u over a times parentheses 2u squared minus 5a squared times square root of a squared minus u squared plus 3a to the 4th over 8 sine inverse of u over a plus c. So I'm going to replace my integral form with the answer, but that 1/2 stays out front. So this comes into negative u over 8, parentheses, 2u squared minus 5a squared. Sure. There you go. Times the square root of, and all I'm doing right now is literally, blow it back down, I'm copying it off the formula sheet, plus square root of a squared minus u squared, plus 3a to the 4th over 8 sine inverse of u over a, and I'm going to close the bracket off of it because that 1/2, and then one big old plus c. So this is literally formula number 37. But now, what do we have to do? Back substitute. This will be 1/2 times negative u. Well, u is equal to 2x, so I put a 2x over here over 8 times 2 times u squared. U squared was 4x squared minus 5 a squared. A squared is 25 times the square root of a squared, which is 25, minus u squared, which is 4x squared, plus 3a to the 4th. A was 5 to the 4th, over 8, sine inverse of u. U was 2x, over a, which was 5, and then your plus c. So all I did, so please, it's basically, with the traditional u substitution, we let u equal to something, du, move it to the other side, and convert the problem completely in terms of constants and u's. And then hopefully it turns into a formula that you have memorized. Here's the change. Instead of turning into a formula you have memorized, now it's going to turn into a formula you can go and look up, because these are the nasty ones. We don't expect you to memorize this stuff. We expect you to know where to look it up at. So, and then the next thing I did, I back substitute. What's the next thing I'm going to do? I'm going to clean it up. This will be 1/2 times. 2 goes into 8 4 times. That'll be negative x over 4, parentheses. 2 times 4. See, this is u squared. Yeah, so 2 times 4 is 8. That'll be 8x squared minus 5 times 25 is 125. Yeah, it just gets better all the time. Times the square root of 25 minus 4x squared plus 5 to the fourth. That's 5 times 5 times 5 times 625. Oh, time for our calculator now. 625 times 8. Gets even better. So 625 times 8. Should be times 3 divided by 8. Times 3 divided by 8 is, crappy fraction, of 1875 over 8 times the sine inverse of 2x over 5 plus c. And this is the correct answer. However, one last thing. They like to put a lot of these kind of problems on the multiple choice part of the test. Traditionally, on the multiple choice part of the test, what they're going to do is they're going to give you a problem, and they're not going to print out the entire back of the book for you guys to look this stuff up. They're either going to tell you, hey, use this formula, or they'll give you a choice of like 3 formulas, and you got to, one of those 3 will help you out integrating this problem. But traditionally, on the multiple choice answer, when that coefficient is out front, they like to clean this thing up by distributing it through. So I'm just trying to prepare you guys for what they're going to do on the final exam. So on the final exam, because they really have 2 terms inside this parentheses, they're going to distribute that 1/2, and that's how they like to type it in. So the answer they're going to type in would be negative x over 2 times 4 is 8, times 8x squared minus 125, times the square root of 25 minus 4x squared, plus 1875 divided by 2 times 8 is 16, times that sine inverse of 2x over 5 plus c. And that is the solution. Typically, they'll give you the plus c part, and there's my answer. Now, exactly, when you look at this problem, and you should be thinking web work, you're going to have to type this thing in. Enjoy. Yeah. Yeah, you can move that paper, won't you? So, but does this make sense, though? It's not hard, but it is incredibly tedious. But the real deal here is this. You know, as a math professor, my job is to prepare you, thank you, my job is to prepare you for your major. And I've got mechanical, electrical, civil, computer science, computer engineering, biology majors, chemistry majors, math majors, physics majors, chemistry majors. I mean, I got the whole gamut of STEM education in this class. So everybody's going to be using this stuff differently. What I'm trying to do is prepare you to handle any part that they throw at you guys. And for a lot of you guys, you're going to be integrating some really nasty functions. And they get really nasty. Here is a major technique that they want you to know. The ability to go, and even though your problem isn't quite a problem we've never seen before, but maybe it does look like a formula that we can use before, and make sure you know how to integrate this stuff. So this is very important material. But I'm going to enjoy web work on this one. All right, so look at this one. The integral of sine to the 5th x dx. First off, 8 sine to the 5th x dx. So 8's a constant. Where do constants get to go? Out front. So I'm not going to worry about that guy at all. 8 times integral of sine to the 5th x dx. Now, with this is a trig problem. And I'm looking at this, and okay, well, usually this is based upon u, but in this one, u would be equal to x, and that would mean du equals dx. So this really is 8 times integral of the sine to the 5th of u du. And I'm going to go look at my tables here, but this one's involving trig, so go to the ones that say involving trig. Here we go, trigonometric functions. And I got to figure out which one of these guys it's going to be. Sine to the 5th. Well, they got sine squared, they got sine cubed, and you keep on going, and what have they got up here? That's right, sine to the n. The formula number we're going to be using, and again, WebWorks going to ask you, what formula number is it? This is formula number 73 in terms of our textbook. Formula number 73. So, here we go. So, pull this thing back down. Here's my problem. This is formula number 73. And this is equal to 8 times, that's the exact form of sine u, sine to the 5th u du. So in this problem, n is equal to 5. Does that make sense? And again, look at your formula, and I'll once again blow it back up for you guys. 73 is the integral of sine n u du is negative 1 over n sine n minus 1 u cosine of u plus n minus 1 over 5 integral of sine of n minus 2u du. But in our problem, n equals what? 5. So I'm going to do is I'm going to copy this formula down, except I'm going to replace all the n's with 5. So here we go. This will be negative 1/5, n equals 5. Sine of n minus 1, 5 minus 1 is 4 of u, cosine of u, plus n, 5 minus 1 is 4, over n is 5, times integral of the sine of n, which is 5 minus 2, which makes it 3 u du. And if you look at this formula, you know where they got it from. Anytime they start out with an integral and it's equal to something or other plus another integral, you know this is it came from integration by parts. Integral u dv equals uv minus integral du. That's how this guy was derived. Now I'm going to clean this guy up by distributing that 8. This is going to give me negative 8/5 sine to the 4th of u cosine of u plus 8 times 4 is what? 32/5 integral of sine cubed u du. Now all I got to do is integrate this guy, which means I got to go look up another formula. This is the integral of the sine cubed guy. Sine cubed, we passed him earlier. He's problem number 67. So this now requires formula number 67. So this is going to be equal to negative 8 over 5 sine to the 4th u cosine of u plus 32 over 5. Here comes my formula number 67, which is negative 1/3 parentheses 2 plus sine squared u close parentheses times the cosine of u, close the bracket, and eventually we got it down to that plus c. So this was formula number 67. So this was a 2-formula problem. Yay. But now, clean it up. And so this is equal to negative 8/5 sine to the 4th of u. But wait a minute. The original problem was in terms of x. Our answer needs to be in terms of x. What was u equal to? U equals x. So I'm just going to go ahead and clean that up. U equals x. So it'll be negative 8/5 sine to the 4th of x times the cosine of x plus, I'm going to multiply this as one big term, all being multiplied, just cleaning up. A positive times a negative would be a negative. That'll be minus 32 minus 32 over 5 times 3 is 15. Just cleaning it up, making it look good. Parentheses times 2 plus sine squared of u, but u equals x. Close parentheses there times the cosine of x plus c. And there's my result. So what you're doing, instead of memorizing the formulas, is going to go look them up and allowing the chart to help you integrate this stuff. So how bad could this stuff be? Well, let's turn page. Let's find out. All right, so here's the next one. The integral of 1 divided by the square root of 3 plus 9x squared. Well, because of that square root, this problem looks like the square root of that a squared, but it's a plus now, plus u squared. Remember, u is the variable. So in this format, I first identify it, and before I start, go grab a chart or something or other. I'm going to see if I can figure out what's going on here. So here, in my setup, a squared would be 3, making a equal to the square root of 3. It also means that the u squared part is that variable 9x squared. That makes u equal to 3x by taking the square root of it. But remember, this is u substitution. Then you got to use du. The root of 3x is 3 dx. Move variable or constant, whatever's in front of that dx, move it to the du side. So 1/3 du equals dx. So when I convert, this is an integral. It's 1 over the square root. The 3 was the a squared plus the 9x squared was the u squared. However, the dx in this problem is a third. Constant goes out front, du. The big trick here is this. You got to keep up with these constants. Because if you mess up the u, the 1/3 doesn't show up front. And I know a lot of people look at this, well, I almost got it right. I just messed up that constant. But that constant is incredibly important. That constant is the difference between literally the bridge making it to the other side of the river versus people dying and it's all your fault because it didn't make it to the other side of the river. Careless error kills. So with this type of stuff, it's either all right or all wrong. You either got the problem right or you killed people. So don't watch the careless errors in this class. Lives depend on it. It's important. So here we go. Now I'm going to go look up this formula here. The square root of u squared plus a squared. Go back to my little charts here. And I tell you these things not to actually joke around with you guys and stuff, but the fact of the matter is, people always come to me after a test and go, I know I messed up the problem, but I only messed it up a little bit. Can't you like give me 9 out of 10 points or something like that? But you kill people, man. You belong in jail. So no, you can't get nothing. You're going to go to jail for life here because you can't do the math. This is science. This is engineering. Watch the careless errors. It makes a difference. All right. Square root of u squared plus a squared. What formula is this guy? This guy is formula number 25. Identify me. It's 1 over the integral 1 over the square root of a squared plus u squared du. So the formula number is 25. So when you see me do these chart problems, I always write down the formula number because that's how they're going to make you guys do it on web work as well. You keep that 1/3 out front. And again, I just want to show you the formula. This one's actually pretty nice because it's short. I like the short ones. It's the natural log, so just copy down natural log of u plus the square root of a squared plus u squared, close parentheses there, plus c. And that's just copying down formula number 25, but remember your constant stayed out front. And then the last one is back substitute. So this ends up becoming 1/3 the natural log of u, and u was 3x, plus the square root of a squared is 3, plus u squared is 9x squared, close parentheses there, plus c, and there's my answer. Your problem is going to occur with problems like this. Now this one, honestly, is not that difficult a problem. But the reason why, this was actually from the last section. But it's also in this section because we got a web work problem like it, and people are frustrated by this problem because they can't seem to find the formula. Let me show you. All right, this is the integral of 1 over x squared plus 2x plus 10. Well, number one, u substitution doesn't work because I would have to let u equal the denominator. U squared plus 2x plus 10. Derivative of that is 2x plus 2 dx. You can factor out the 2, great, but there's no x plus 1 dx waiting for you in this problem, so u substitution is not going to work. And it's in the section of, you should be looking for tables, so we're going to look for tables. The problem is tables are in the form of this u squared plus or minus a squared look, right? Which means, what do we have to do to convert x squared plus 2x plus 10 into a u squared plus or minus an a squared? Well, no, not factoring. Factoring is going to turn into a product. I want it to be u squared plus or minus a squared. I got to complete the square. So this is going to require complete the square on this stuff. Complete the square. So here we go. I got x squared plus 2x, leave a little space, and then put plus 10. I noticed that the coefficient in front of the x squared is a 1, so this makes it an easier type of problem. I identify the b term. The b term is 2. To complete the square, I take half the b term, and I square it. Half of 2 is 1 squared. 1 squared is 1. The magic number to complete the square for this problem is 1. So I'm going to go in there and add that 1 to the x's, but to maintain balance, what do I have to do? Subtract 1 from the constant, because this is an expression, not an equation. What I giveth, I taketh away. So then, this part is going to clean up. The x squared plus 2x plus 1 is going to factor into x plus 1 times x plus 1, plus the 10 minus 1 is 9. I mean, you guys had a point there. Maybe this thing could have factored, and then I could do partial fractions on it. You're right about that. But it's x squared plus 2x plus 10. What times what is 10 that adds up to be 2? Nothing. Okay, so it doesn't factor was my point here. But if it did factor, you're right, I could use partial fractions on it. But I'm sorry, I realized this thing didn't factor because the only thing factors of 10 are 2 and 5, and 2 and 5 make 7, not 2, so it officially doesn't factor. This is a u squared plus a squared complete square problem here. So this thing turns into x plus 1 squared plus 9. So this is the integral of 1 over x plus 1 squared plus 9 dx. And what does it look like? Well, to me, this problem looks like the integral of 1 over u squared plus a squared du. With me? And that's a form you actually supposed to have memorized. That's equal to 1 over a arc tangent of u over a plus c. So in this problem, the u squared is equal to the 1 plus x squared, makes u equal to 1 plus x, which makes du equal to dx. Root of x plus 1 is just 1 dx. It also means that the a squared is equal to 9, making a equal to 3. So this is actually a complete and easy substitution of 1 over u squared plus a squared du, which is equal to 1 over a arc tangent of u over a plus c, and I back substitute 1 over a is 3, arc tangent of u, which is x plus 1 over a, which is 3 plus c, and there's my answer. And don't forget to put parentheses around your numerator there. So we got it. But the reason why we put this one on the notes is because of this right here. People are getting, almost all the credit for this one, except for one thing. You're supposed to tell me what formula number this is. And they look and look and look where the a squared plus u squared look, and the a squared plus u squared, that formula isn't there. The reason why it's not there is the formula you're supposed to have memorized. And I told you guys, the ones you're supposed to have memorized are the first 20 of them. And it's actually formula number 17. So when they ask you the formula number, it's not where you think it's going to be. It's formula number 17. And it is actually from the first section of the easy formulas and stuff like that. You'll run across a couple of them that are actually the basic ones you're supposed to know. So what do I need to tell them an easy formula? Well, that's because it's web work and they're asking for it, and this is how you get your points. So this is formula number 17. But it's the classic arctangent problem, complete the square, which we did last section. All right? So how bad could it be? Well, we'll take a look at some of these interesting web work problems I got for you. All right, so I tried to kind of copy it down here of what WebWork's going to do for you guys. So we're supposed to use the table of integrals to evaluate the integral of 11 over x squared times the square root of 16x squared plus 49. And I don't know what happened. Oh, there, the dx is up there. All right, dx, I always stick the dx in the back. There it is. All right, so first things first. Before you start going to go clamor around for a formula, write it properly. This looks like forms involving the square root of u squared plus a squared. Here, u squared, this is the stuff inside the radical, so the u squared is 16x squared, and the a squared is equal to 49. That makes u equal to 4x, and it also means that a equals 7. So far, so good. But remember, this is u substitution. So u equals 4x. Then you take derivative. Derivative du. What's derivative 4x? It's 4 dx. Whether it has a variable or a constant, don't care. Solve for the dx. Move it to the du side. In this case, I got 1/4 du equals the dx. And you're going to see an issue here. So here it comes. So when I plug it in, this is the integral of 11 is a constant. Just leave them alone. Divided by, this is the square root of, this was your u squared plus a squared. The dx got replaced with, and I'm just going to show you, literally plugging in 1/4 du, and there's a problem. There's an x squared that never got substituted for. So what you have to do is you've got to go back to your u statements and figure out, okay, what does x squared have to be in terms of u? Well, since u squared is equal to 16x squared, that makes x squared equal to u squared divided by 16. So this would be equal to the integral of 11 over u squared divided by 16 times the square root of u squared plus a squared. And then I got 1/4 du. And again, I wrote it this way because I wanted you to see the literal substitutions problem. Now here comes the problem that's going to cause people fits. What's my next move? Bring out all those constants out front. All right? And when you bring out these constants, just want to show you. 11 is a constant, it's going to go out front. 1/4 is a constant, it goes out front, times 1/4. The problem is you've got this division and you've got a 1/16 in the denominator. So he's going to pull out front as 1/16 in the denominator. There's all my fractions, all my constants being pulled out with fractions there, of the integral of, it'll be 1 over u squared times the square root of u squared plus a squared du. Now, when you divide by a fraction, what do? Invert and multiply by the reciprocal. So that 16 is going to show up on top. What's 1/4 of 16? 4 times 11. 44 is what this number turns into. Times the integral of 1 over u squared times the square root of u squared plus a squared du. Now is when I start to go look for the formula table. This is forms involving this u squared plus a squared. They're up front. And it's u squared on the bottom with a u squared and a squared. That is formula number, let me blow it up for you guys. What number is it? Number 28. So this is formula number 28. So the formula number is 28. And so this would be equal to 44, the constant out front, bracket, and I get to replace this with formula number 28, which is negative the square root of a squared plus u squared divided by a squared u plus c. That's formula number 28, replacing 44 constants, hangs out front, replacing the integral. So here we go, back substitute. This would be 44 times negative the square root of a squared was 49, plus u squared is 16x squared, divided by a squared, which is 49, times u. What is u equal to? 4x plus c. And traditionally, you want to clean this guy up. So positive times negative makes it a negative. And I got here 44 divided by 4. See, that 4 will go into 44 11 times. So this will be 11 over 49 times the square root of 49 plus 16x squared divided by, don't forget the variable down here, x plus c. There is the solution. So even the cleaning up of this stuff is what typically gives people a little bit of fit once they actually get the formula. But remember, it's u substitution. And whenever you let u equal 2, you take its derivative and whatever's in front of that dx, move it to the du side, and then with the stuff that's left over, you're going to have to come somehow through your stuff is solve for, in this case, the x squared, and turn it in terms of u. That was u squared over 16. And then go look for formulas. So that being the case, take a look at the next guy. Use a table of integrals to evaluate the tangent cubed of 4z over z squared dz. Oh, and by the way, I forgot to mention one other thing. They occasionally on this problem, and I left my little blank there, sorry. You've got to tell what u is. What was u in this problem? What did we let u equal to in this problem? U was equal to 4x. So on web work, they will occasionally ask you for that. What are you going to let u equal to? You start with these forms, you start with u squared, and then you get down to the u. Same idea here. Use the table of integrals to integrate the tangent cubed of 4 divided by z squared dz. All right. So before I start figuring out what u is, and before I figure out formula, I'll just rewrite the problem. This is the tangent cubed of 4 over z divided by z squared dz. Now, this is a trig problem. And when you look up the forms involving trig, let me grab that one wherever I happen to put that little section there. Forms involving trig. Oh, there it is right there. What is u equal to in every one of these forms involving trig? It's the angle on the trig function. Catch a pattern. Does that make sense? It's the angle on the trig function. So for this one, it's pretty obvious. You're going to let u equal to what? 4 divided by z. which is the same thing as 4z to the negative 1. Because with trig problems, u is the angle on the trig. So, but it's u substitution, so you got to do du. What's the derivative of 4z to the negative 1? This is going to be negative 4z to the negative 2 dz. Does that make sense? Cleaning them up, this is du is equal to negative 4 over z squared dz. And solve for the dz. To solve for the dz, I'm going to multiply both sides by z squared and divide by 4. That gives me z squared over negative 4. du is equal to dz. I don't care what's in front of the d independent variable, in this case dz. You move it to the du side, and we're going to substitute. So now substitute. This problem turns into the integral of the tangent cubed of u. The dz is negative z squared over 4 du, and there is a z squared on the bottom. Clean it up. What happens to my z squareds? They're going to cancel. Pulling my constant out front, this problem now turns into negative 1/4 the integral of the tangent cubed of u du. Now I'm going to go look for a formula number. All right, so if this is the integral of tangent cubed, we happen to have that. And just to show you where it's at and blow it up for you guys that are in the back here, because these are typed in micro and font and 0 type thing here. Tangent cubed is formula number 69. Does that make sense? So this is formula number 69 that we're going to be using here. So type that in onto your web work. And keep your constant out front, negative 1/4. And so here we go. Formula number 69 is 1/2 the tangent squared of u plus the natural log of the absolute value of the cosine of u. Close the bracket down, and then your plus c. And that's literally formula number 69. Back substitution, this is negative 1/4 times 1/2 the tangent squared of u. Well, what's u equal to? 4 divided by z plus the natural log, the absolute value of the cosine of u, which is 4 divided by z, absolute value, plus c. And honestly, if it's a free response question or you want to type this in on Weber, absolutely fine. Perfect. However, on a multiple choice test, they are going to take that constant that you had to keep up with, which was your negative 1/4, and on the final answer, they're going to distribute through each term of your integral. So they're going to distribute this 1/4. So if it's a multiple choice question, the answer that you would have seen in terms of A, B, C, D, E would be negative 1/8 tangent squared of 4 divided by z minus 1/4 the natural log of the absolute value of the cosine of 4 divided by z plus c. That's what the multiple choice answer would look like. And again, you would, in this problem, you would let u equal to 4 divided by z was the trick. Does that make sense? Well, can they get nastier? Oh, yeah. Sweet. So, turn the page. Here's a winner. Try this one. All right. Use the table. Well, I've been setting you up for this one. Use the table of integrals to evaluate the integral of y times the square root of a negative 11 plus 12y minus y squared dy. What are you going to let u equal to, and what formula number? You know you're in trouble when they give you a whole page to work this problem out. So here we go. First thing you'll notice is this. We're integrating a square root. And when we integrate a square root, it's got to be one of those square roots of u squared minus a squared or a squared minus u squared stuff. What have they got underneath the radical on this guy? They got underneath the radical is what I'm paying attention to. You've got the negative 11 plus 12y minus y squared. That's right. They were just being mean. Why would you want, it's a quadratic, but why in the world would you ever write a quadratic with a minus y squared in the back? That's just wrong. So this is negative y squared plus 12y minus 11. And because it's a square root in the problem, we got to turn it into that u squared, a squared minus u squared look. That's really what we're going for here. which means to get that perfect square plus or minus perfect squared stuff, what do I have to do? Complete the square. Now, remember our trick on completing the square. To complete the square, you need to have the coefficient in front of the squared term to be a 1. What do we got in this problem? Negative 1. So I'm going to factor out the negative 1 out of the y's. That'll give me y squared minus 12y. Leave a little space, close parentheses, and push your constant on the back, minus 11. I factored the coefficient in front of the y squared out of all the y terms. Does that make sense? Now, to complete the square, you've got to take half the b term. My b term is negative 12. And we're going to square it. So here is your complete the square term. Take half the b term and square it. What's half of negative 12? Negative 6. And what is negative 6 squared? 36. That is your magic number. I'm going to put plus 36 inside the parentheses. But I've just added something foreign into my problem. It is now unbalanced. I got to maintain equality, so I need to balance it. But by putting this plus 36 inside the parentheses, what overall effect does it have? Because of that negative 1, that's a magnifier, multiplier out front, by putting a plus 36 inside the parentheses, I've really subtracted 36. Negative 1 times plus 36 is minus 36. So to maintain equality, since I subtracted 36, I need to add 36 to maintain balance. Does that make sense? Do you understand? That is really a negative 36 right there because of that negative 1 being multiplied out front. So this will now turn into negative 1 times, how does y squared minus 12y plus 36 factor? It will be y minus 6 squared. And what is minus 11 plus 36? Don't hurt yourselves. 25, good. 36 minus 11 is 25. So, of course, we want to write it in the proper form. We like to put our positive stuff up front. So, this is 25 minus y minus 6 squared. That's what it's turned into. Does that make sense? So now, rewriting this problem now turns into the integral of y times the square root of this negative 11 plus 12y minus y squared through the complete the square turned into this guy. So it's the integral of y times the square root of 25 minus y minus 6 squared dy. Does that make sense? Now, I start thinking about forms. Now, noticing this is forms involving, it looks like an a squared minus a u squared. You with me? So here, the a squared would be equal to 25. The u squared is going to be equal to the y minus 6 squared. That makes u equal to what? Y minus 6. And that also means du is equal to, get rid of y minus 6 is just 1 dy. I don't have anything to move to the other side. Also, if a squared equals 25, a equals 5. So far, so good? Now, plug it into our formula. This turns into the integral of the square root of, this is a squared minus u squared. dy is du, and I got a problem. No, somebody didn't get substituted for. It's going to happen to you. Does that make sense? But how do I get it? I got to convert it to u. Go to your u statement. U equals y plus, y minus 6. What does that mean y is equal to if you solved it for y? U plus 6. Oh, it's going to get better for a second here. U plus 6. So I'm going to now convert it over. This becomes the integral of u plus 6 times the square root of a squared minus u squared du. Now, if you start going to look for formulas, this is formulas involving a squared minus u squared. So a squared minus u squared. Let me grab through my sheets here. A squared minus u squared is up here, starting at number 30. Look at this formula. U plus 6 times the square root of a squared minus u squared. I don't see a u plus 6 in front of this square root, so it's not there, but wait. I do have a u, I do have a square root of a squared minus u squared. There it is right there. Formula number 30. So here comes the trick I'm going to show you guys. The answer is formula number 30, but wait, let me show you. This is actually equal to, because we don't have a constant, what I'm going to do here is I'm going to distribute this square root of a squared minus u squared. And I'm sorry, but this is the problem. It's going to turn into two problems. It's going to turn into the integral of u times the square root of a squared minus u squared du plus 6 times the integral of the square root of a squared minus u squared du. Does that make sense? I distributed this guy so you get u times the square root plus 6, but 6 being a constant, I pulled it out front and in front of that integral. So it really turned into two problems because of that u plus 6. Does that make sense? Now, this guy is a formula. Constants don't matter. This is formula literally number 30 right here. So your formula number is number 30. So that constant 6 hangs out front. Formula number 30 is u over 2 times the square root of a squared minus u squared plus a squared divided by 2 sine inverse of u over a plus c. And all I did was copy down formula number 30. Okay? And over here, now I'm going to figure out what formula number this is, so look for it. U times the square root of a squared minus u squared. Look at this guy and tell me where u times the square root of a squared minus u squared is. Here's square root of a squared minus u squared. Just used him. What's the next formula? It's u squared times the square root of a squared minus u squared. Then the u's on the bottom, u squared's on the bottom, u squared's on top, u square root's on the bottom, square root's on the bottom. Then you got your, where's it at? It's not there. You know why it's not there? Because they don't put the easy formulas on the table. They only put the hard ones. So if you don't see it, that meant it must have been an easier problem. So here's what you're supposed to do. You're supposed to recognize that, hey, I don't do square roots. What's a square root? Half a power. I've already used u, so I'm going to do something called w substitution. I'm going to let w equal to inside parentheses, a squared minus u squared. What does that make dw equal to? Well, a is a constant, so the root of a squared is 0 because a is a constant. Minus, what's the root of u squared? 2u du. And if you notice, there's a u du in the problem. So this is mental in your head. Hey, if I let u, or in this case w, equal inside the parentheses, the derivative is actually in the problem. I can move the constant to the other side. Negative 1/2 dw is equal to u du. So this turns into an integral of w to the half. The u du turns into the negative 1/2 dw. So when I integrate this, this will be negative 1/2. Integral of w to the 1/2, add 1 over add 1, is w to the 3/2 over 3/2. Invert multiply, that'll be negative 1/2 times 2/3 w to the 3/2. So that turns into negative 1/3, because the 2's cancel, w to the 3/2. And w was negative 1/3. What was w? It was a squared minus u squared to the 3/2. So all that gives us this. And then I'm going to put plus, and I'm going to go ahead and distribute this 6 throughout, just to clean him up, to get a complete answer here. What's 6 times u over 2? Well, 2 goes into 6 3 times. That'll be 3u square root of a squared plus u squared. Plus, 2 goes into 6 3 times. That'll be 3a squared times the sine inverse of u over a plus c. But we're not done. Wait. What was the original problem? Yeah, I had something weird with y's in it, right? So we got to have an answer in terms of y. So go back and substitute in for y and a. A was 5 and u was y minus 6. So the answer is negative 1/3 a squared, that would be 25, minus u squared, which is y minus 6 squared, close parentheses to the 3/2 power, plus 3 times u was y minus 6, times the square root of a squared, which is 25, plus u squared, which is y minus 6 squared. That's a minus there. What did I copy? Let's see here. That's a minus. Sorry. Typo. Minus. Put a minus there. That was a minus. Minus. So it's u squared, a squared minus u squared. That's a minus. I was too happy on getting the answer here. Plus 3a squared. What's a squared? 25 times the sine inverse of u, which is y minus 6 over a, which is 5, plus c. Yeah, I know I squeezed it in, but don't worry, I'm going to write it one more time. So therefore, my answer is negative 1/3 times 25 minus y minus 6 squared to the 3 halves, plus 3 times y minus 6 times the square root of 25 minus y minus 6 squared, plus, clean up your constant here. What is 3 times 25? 75 times the sine inverse of u, which is y minus 6 over a 5, plus c. And boom, 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 the actual answer. Yeah, you know there's a web work problem waiting for you just like this. But remember, on this problem here, the real trick was once I did this u, substitute in for the y after completing the square, you had to distribute and it turned into 2 problems. Remember this. The first problem with u out front is actually a u substitution problem that's not a formula in the book. You're expected to do that. The second problem is actually the table. So to go back and answer the question in terms of web work, what was u equal to? Y minus 6. And what formula number we end up using? It was formula number 30. That actually answers the question on this thing. And as well as you got to type this in on web work. So this is why, I mean, these guys, they are going to be a little bit more tedious in doing. It's not tough, but it's tedious. But don't forget to keep up with your constants. And typing this stuff in the web work is going to be interestingly challenging. That's why you have unlimited attempts. Good luck. Go home and work on this stuff. And I'll see you guys on Monday.